Okay, I had a few questions about assignment 2.5, this part of it specifically, where it gives you this kind of funny dogleg shape and wants you to find this missing dimension up here. So there are a couple different ways you can do this, kind of like it said in the assignment. One of the points of this little mini assignment is to show you that there are multiple ways that you can solve a problem like this. There isn't just one way. So I'll show you a couple ways that you can do it. One of the ways it mentions is by sketching. You can see I just sketched it out here. A word to the wise with sketching this is that I would suggest doing it, you'll notice that it's unitless. The assignment doesn't say that this is 4 inches or 3 inches or 1.5 centimeters. You can do it in any units you want. I tried doing it in centimeters first. You can see on my handy dandy ruler here I've got inches and I've got centimeters. So I tried doing it in centimeters first, but doing it in centimeters, I drew it correctly, but when I entered the answer, I ended up getting it wrong just because I wasn't close enough. I wasn't able to draw it accurately enough in centimeters to get it to be close enough. But when I switched to inches and I drew 4 inches, I could draw it pretty accurately, and so I ended up getting it right when I drew it in inches and then just measured this distance here. So when you sketch it, you just draw it out, make sure that you use a protractor of some sort to get that angle, that 45-degree angle right, and then make sure that these are true 90s. That's one thing that you'll want to be sure is that those are actually 90-degree angles, because when you come down, this intersection is key when you're sketching it. So if you do that, then you should be pretty good sketching it. So if you just want to sketch it and measure it, awesome. That's a great way to do it. You can stop the video here and go on. If you want to figure out how to do it using a little bit more trig, or at least the way I figured it out using some kind of geometric principles, I don't know if it's true trigonometry, then let's look at this side of it. So when I was looking at this, I'll be honest, I've done this in past semesters and I remembered how to do it all the semesters except for this semester. For some reason my brain blanked the other night when I was trying to help someone do it this way. So I had to puzzle it over for a little while, and I finally, I think, figured out the way that I remembered how to do it before. Maybe it's a totally new way, who knows. But the way I was looking at it, I felt like, look, this is really, it's two rectangles that are pivoting about this point relative to each other. So let's kind of say, okay, we've got one rectangle that is 1.5 by 3, so 1.5 by 3, and another one that is 1.5 by 4. And if I were to have this angle pivoting about this point be 0 or 180, either way you look at it, then the total length from here to here would be 7, right? And then if instead I took this situation and I said I'm going to have them be at a 90-degree angle to each other, I'm going to make this right angle right here, so I just took it, instead of having it this way, I went and made it a right angle, then the distance would be this 4 minus this 1.5. It's 1.5 up there, it's 1.5 down here, it's 1.5 right here. So 4 minus 1.5 is 2.5. That would be the distance here. Now, what if instead I rotated it, like the assignment, 45 degrees? What would be the distance from here to here? It seems a little bit trickier, right? Well, it is, to be honest. At least it tricked me for a while. But what I was looking at and finally had it kind of dawn on me is that if I were to take this line and if I continued it up, it would intersect there at the same point as if I did the same thing up here. If I drew a line between there and there, this point up here is the same point as this right here. So that's 1.5 from there. This is 1.5 all the way up and down, right? So if I were to draw a triangle right here, then I know what this base is. It's 1.5, just like it was up here. And because this is a 90-degree angle, and this is also 1.5 all the way across, I know that this side of the triangle is 1.5, so I have a triangle with a 90-degree angle, two sides that are the same length. That means that these angles are going to be 45, right? Am I taking you back to like 8th or 9th grade geometry? Thinking of triangles here. So we've got a 45, 45, 90 triangle with legs that are 1.5 whatevers each. inches or centimeters, whatever you want to call them, yards, miles. And then what that does for us, you might be saying, well, that doesn't help me with this. Well, hold on a second. It might, and it actually does. What that will do is, notice that I've drawn, maybe inadvertently, another triangle up here that is also a 90-degree 45, 45 triangle. This little guy. And it just so happens that since I know what this distance is from here to here, and I know that this total length along the bottom is 4, right? Remember, that's 4 from there to there. And now we know this from here to here is 1.5. That I also know what this distance is. This is 2.5. Just like we saw up here, right? This was 2.5 up to that point. So from here to here is 2.5. So if I can figure out this length, then ta-da, I know what this is because I can add this and the 2.5. So our goal is going to be to figure out what this triangle's length is. But that's where you run into a little bit of a conundrum. Well, how do I get this? Because I don't know this length and I don't know this length. What finally hit me was something, if you guys might remember, something called similar triangles in school. So what if I took and drew a line down there? What if I drew from this point, this imaginary point that doesn't really exist on the assignment, right? If I were to take this and not stop here where it intersects, but keep going as if this were a 1.5 by 3 rectangle like we set up here, right? So where's this point? And then I drew a line straight down. This little triangle right here is similar to this bigger triangle that we've been talking about, that we know the 1.5 and 1.5 and the 45, 45, 90, right? Because this angle is also 90. We drew it straight down, so it's a 90-degree angle. And we've got this angle right here, 45. This angle also has to be then, by definition, a 45-degree angle. And you're going to say, but we don't know any of the lengths. Don't we? We do, actually, because look at this. This is 1.5. And it's 1.5 here, and here, and here, and here, and here, and here. 1.5. So now I know that this is 1.5, and I know that this triangle, the other, so I've got this little triangle in here, which is a similar triangle to this triangle right here. And I can figure out what this length is, and I can figure out what the hypotenuse of this bigger triangle is. I'll draw them off here to the side so you can see what I'm saying. We've got our small triangle, and we know that its hypotenuse is 1.5, right? Right here. And we know it's a 45, 45, 90 triangle. We don't know the legs yet, but we don't care right now. We also have the bigger triangle, which, despite my poor drawing skills, is a 45, 45, 90 triangle, and we know the legs of it, 1.5 and 1.5, right? The question is, what's the difference between this hypotenuse length and this hypotenuse length? Because that's this distance right here. And that is key to helping us figure out this triangle and its hypotenuse, and thus that. So I'm going to leave it at that for you guys and let you figure it out from there. But one key with this little piece of the triangle is to realize that this is a 90, 45, 45, and you're trying to find this hypotenuse. Given these similar triangles, you guys can get that.